So we are here at lesson 3.6. This is brought to you by Alonzo Productions, Inc. And we want to talk about the discriminant as well as how to know which method to use when solving a quadratic equation. Our goals are to be able to use the discriminant to determine which method is appropriate for solving any given quadratic. And the discriminant is kind of a fun little formula that we're going to talk about. So, whoops. The discriminant is given by this formula here, b squared minus 4ac. And then it tells you a couple of different things. First, that the thing that the discriminant tells you is how many real roots something has. In other words, not imaginary, no i's. So if the discriminant is bigger than 0, there are 2 real roots, meaning you will have no i's in your answer. If the discriminant is equal to 0, so when you plug the numbers into b squared minus 4ac, you get 0, there is 1 real root, and that means that it's a double root. So you might have like x minus 3 times x minus 3. That's what's going to happen there. And if the discriminant is less than 0, so if the discriminant is a negative number, there are no real roots, meaning you have i's in your answer, okay? So we can first of all use the discriminant to tell us how many real roots, remember those would be points where the graph crosses the x-axis, the x-intercepts, that a quadratic function has. So let's try this out. We've got here 9x squared plus 3x plus 11. Remember that 9 is our A, 3 is our B, and 11 is our C. We're just going to plug this into the discriminant formula. So I'm going to take b squared, so 3 squared, minus 4 times 9 times 11. Now this should look very, very, very familiar because the discriminant is actually part of the quadratic formula. So we've done all this before, we're just not doing the full quadratic formula, okay? So we're going to take 9, which is 3 squared, minus, and then we're going to take 4 times 9 times 11, which is 396. And when I subtract 9 minus 396, I get negative 387. This is a number that is less than 0. Therefore, there are no real roots. So if I go on to solve this, I will have an I in my answer. Now we're talking a little bit about which method to use. If your discriminant is negative, you're going to need to use the quadratic formula most likely, okay? Just because you can't factor when there are i's, you can't really solve by square rooting when there are i's, you can, but it's kind of difficult. And completing the square is probably not an option most of the time here, okay? Let's talk about another one. I have negative 6x squared plus 15x plus 8. So negative 6 is my A, 15 is my B, and 8 is my C. I'm going to use my discriminant again, b squared minus 4ac, and I'm going to plug the numbers in. So 15 squared minus 4 times negative 6 times 8. 15 squared is 225. And then I'm going to have 4 times negative 6 times 8, which gives me negative 192. And remember that when I am subtracting a negative, it becomes plus. So 225 plus 192 is 417. This discriminant is greater than 0, therefore there are 2 real roots. I will not have any i's in my answer. From here, we're going to talk about in a couple minutes about how to determine which method to use to solve then once I know that I have 2 real roots. So looking at this one, I would encourage you to pause the video and try to find the discriminant yourself and then compare so that you can see if you know how to do this. So I'm going to plug in my A, my B, my C into the formula, and I'm going to take 4 squared minus 4 times 4 times 1. 4 squared is 16, minus 4 times 4 times 1 is also 16, and I end up with a discriminant of 0, which means there is 1 real root. Okay? So hopefully you figured that out. The discriminant's not too terribly difficult, and it tells us, first of all, how many real roots a quadratic has. In other words, how many times or where how many x-intercepts do we have? How many times will this cross the x-axis? The discriminant is a perfect square, then the quadratic can be factored. So the discriminant tells us a little bit more too. It tells us not only how many real roots there are, but if we get a number that is a perfect square, we can factor. So let's work with this a little bit. Again, I'm going to use my A, B, and C, and I'm going to plug these into the discriminant. I would pause the video again, do this real quick, and make sure you know what you're doing, okay? I'm going to take negative 13 squared, 4 times 5 times negative 6. This is 169. And 4 times 5 times negative 6 is negative 120. I'm going to be adding, because subtracting a negative is adding. So 120 plus 169 is 289. Now, 289, I know that if I square root that, I'm going to get an integer answer, which is 17. So this is a perfect square. 289 is a perfect square, which means that I can go back up and I can solve this by factoring. So I'm going to use my two sets of parentheses. I'm going to find the factors of 5 and the factors of 6, and I'm going to get them to subtract to be negative 13. I'm going to start with 1 and 5 because those are the only factors of 5, so I have to use them. And then I'm going to try to figure out 6. I'm feeling like 2 and 3 is probably a good choice here because this gives me 10. This gives me 3, but 10 minus 3 doesn't make 13. So let's try switching the 2 and the 3 and see if we can make that work. So 3 and 2. Now I have 15 and 2, and I can use 15 minus 2 to make 13. And I want it negative 13, so I'm actually going to do negative 15 plus 2. That gives me my negative 13. My last thing is to solve. So I'm going to take x minus 3 equals 0. I'm going to solve that and get 3. And then I'm going to take 5x plus 2 equals 0. I'm going to solve that, and I'm going to get negative 2/5. Those are my two solutions, which I found by factoring. The reason I know to factor is because the discriminant is a perfect square. So once I find the discriminant, that kind of leads me into which of my 4 methods is the best choice. Remember, my options are square rooting, factoring, completing the square, or using the quadratic formula. So how do we know which method that we should be using? Our first option is square rooting, and remember that we want to choose that if there is no middle term. So when we have something, for example, like x squared plus 14 equals 0, there's no bx term, so on this, I want to solve by square rooting. That's going to be the easiest method. Our second choice is factoring. This is easiest if a is 1. So if I have something like x squared plus 5x plus 6. Okay, a is 1. That's going to be pretty easy because then I only have to find the factors of 6 that add to be 5. Also, if I do the discriminant and I find out that the discriminant is a perfect square. So if I get the discriminant, b squared minus 4ac, and that equals a number like 1 or 4 or 16 or 225 or 400, any number that can be square rooted and get an integer answer. That tells me that my quadratic is factorable. Now, if I get a discriminant that is not a perfect square, I know I'm on to methods 3 and 4. I either have to complete the square or I have to use the quadratic formula. Completing the square is a little bit easier. However, it really only works well if a is 1 and b is even. So if I have something like x squared plus 10x plus 19 equals 0, okay? That's going to be good for completing the square. If I have something like 2x squared plus 3x minus 14, that's not going to be a good one to complete the square with, okay? Because I have an a that's not 1, my middle term is not even. Which then leads me to last choice, the quadratic formula. The quadratic formula works for every quadratic. However, it is not your best option. It is your last resort. The quadratic formula is very complicated. It is very, very, very easy to make a mistake when you are doing it. And it takes a lot longer um, to solve the problem, and you have to make sure that you simplify and you do an I and all of the different things. So it really is sort of your last resort. If none of the other methods work, then you want to go the route of the quadratic formula, okay? So looking at this here, let's talk about what we can do. First of all, we know that square rooting is out, okay? There's a middle term, so there's no way that we can solve by square rooting. Let's talk about factoring for a second. A is 1, which leads me to believe that this might be good for factoring. However, I'm going to check the discriminant just to see. So I'm going to take b squared minus 4ac. So I have negative 6 squared minus 4 times 1 times 11. And I'm going to get 36 minus 44, which is a negative number. Therefore, this is not factorable. Okay? I also can look at it, and I know there's no factors of 11 that are going to add to be negative 6. Not a possibility. So now my options are completing the square or using the quadratic formula. Now A is 1 and B is even. So I'm feeling like completing the square might be a better, quicker option here. So I'm going to do that one. So I'm going to say x squared minus 6x. I'm going to put in my blanks. Remember doing this? If not, refer back to our video on completing the square. I'm going to take half of 6, which is 3. Squared is 9. I'm going to factor over here into x minus 3 squared. And then negative 11 plus 9 is negative 2. I hope that you are feeling comfortable with completing the square. We use this for several different things. And once you're comfortable with it, it is a pretty quick process because you just square root both sides. I know I'm going to need an I, square root of 2, and then I'm just going to move my constant over. There we go. So completing the square, method number 3, was a good option here. We were able to do that pretty easily. If I had used the quadratic formula, I would have had to simplify and reduce the radical, and I really don't like to do that. That's a lot of work, and it's easy to make a mistake. So completing the square, yes, is a longer process than factoring, but is still better than the quadratic formula if you can avoid it, okay? So we checked the discriminant. We found out it was not factorable. We went to method 3 and chose to complete the square because A was 1 and because B is even. Looking at this one here, remember that method 1 is solving by square rooting. We're looking for no bx term, which this does not have. So this right away tells me I should solve using method 1. I'm going to square root. So I'm going to start by subtracting 21 to the other side. I'm going to divide by 3, and then I'm going to square root. And I have an I because my radicand is negative, so I'm going to have plus or minus I square root of 7. I can't simplify the square root of 7 any farther, so I'm going to leave it like that. So method number 1 here was the best option because we had no bx term. And look how easy that was. We just solve it and we're done. Let's look at one more here. This one looks pretty complicated. I got some big numbers here. Looks kind of difficult. So I'm going to start. I know that square rooting is out. I'm going to start by checking the discriminant. I am guessing that this is not factorable, but I want to see just to be sure. So I'm going to put these numbers in, and I'm going to find 12 squared is 144, and then 4 times 7 times negative 19 is negative 532. Remember that when I'm subtracting a negative, it becomes positive. So I'm going to add 144 and 532, and I'm going to get 676, which I'm just going to check to see if that has a square root. It does, so this is actually factorable, believe it or not. However, I'm not sure that I want to really try to factor this. So I think I'm going to use the quadratic formula, just because trying to factor 19 and 7 and make that work out might be kind of difficult. I could probably do it. But here's the thing. By checking the discriminant, I already have the quadratic formula mostly done. So I'm going to so remember that the quadratic formula, I'm going to write it here, negative b plus or minus the square root of b squared minus 4ac all over 2a. Look, I already have my b squared minus 4ac part done. That I know is 676. So the quadratic formula by doing the discriminant just got a little bit easier. Now I just have to fill in the other stuff. So I'm going to take negative b, so negative 12, plus or minus the square root of 676 over 2 times 7 is 14. I'm just going to multiply that right away instead of writing it out. Now, I just checked on my calculator, and I know that the square root of 676 is 26. So I'm going to do that, and then I'm going to simplify. When you end up with a number that actually square rooted, and we have something like this, so negative 12 plus or minus 26 over 14, we can evaluate that. So we're going to take negative 12 plus 26. If you're using a calculator, this is the point where you hit enter, and you get 14 divided by 14 is 1. Then you do the same thing, negative 12 minus 26, hit enter again, divided by 14, and we're just going to leave that as a fraction because it makes kind of a not very nice decimal, and we're going to just leave it as negative 19 over 7. It was 38 over negative 38 over 14. We're just going to reduce that, and we get negative 19 over 7. There's my two answers. Now, again, I probably could have factored this as well. But once I do the discriminant, I've already got the quadratic formula halfway done. On a problem like this where I've got some big numbers and to try to make those work, I'm just going to continue with the quadratic formula. So in this case, the choice is yours, which direction you want to go, okay? I hope this has helped you figure out which method is best for solving a quadratic, looking for some of those clues, using the discriminant, not only to tell you how many real roots it has, but also to tell you how to solve or which method might be the best. I hope that kind of makes sense for you and that you can use this now as you are solving quadratics. As always, this has been a production of Catalonzo Inc. We are here to help you learn math topics and to answer any questions that you might have. So let us know. Take care.